Welcome to Mission APSC AJ YouTube channel. আজি আমি ডিসকাস কৰিব লৈছো fluid mechanicsৰ এটা important topic that is force and power requirements due to viscosity. Okay? So viscosity কাৰণে force আৰু power requirement কেনেকা হয় সেই গোটেইখিনিৰ বিষয়ে আজি আমি ডিসকাস কৰিম। যদি আপোনালোকে চেনেলটো নতুনকৈ আহিছে then please like, share and subscribe কৰিব so that মই 1000 subscriber সোনকালে কমপ্লিট কৰিব পাৰো। So যিমানখিনি APSC ৰিলেটেড সিলেবাস হয় সিভিল ইঞ্জিনিয়াৰিঙৰ লগতে নন টেকনিক্যাল পাৰ্টটো সেই গোটেইখিনি মই কভাৰ কৰিব ট্ৰাই কৰি আছো এই চেনেলটোৰ যোগেদি। যদি আপোনালোকে ছাপোৰ্ট কৰে দেন মই মোৰ নাম্বাৰছ অফ ভিডিঅ'জ আপলোড কৰিম। যদি আপোনালোকে চেনেলটো চাই ভাল লাগে বা আপোনালোকে এই ভিডিঅ'টো চাই উপকৃত হোৱা বুলি ভাবে দেন প্লিজ কমেণ্ট ছেকশ্যনত জনাব আৰু লগতে যিটো লাইক বটম আছে সেই লাইক বটমটো প্ৰেছ কৰিব। অ'কে, চ' আজি আমি ডিছকাছ কৰিম ফ'ৰ্চ এণ্ড পাৱাৰ ৰিকুৱাৰমেণ্টছ। So first of all, power কি হয়? Power is basically the amount of energy transfer, right? So power to আমি physicsত পঢ়ি আহিছো। Power এটা relationship আছে, power is nothing but আমাৰ যিটো applied force হয় তাৰ লগত কি কৰো velocity multiply কৰো। সেই কনসেপ্টটো ইয়াতো ইউজ হ'ব। So we'll try to discuss one by one. So first of all, parallel plate কি হয়? Parallel plate means this is one plate, this is one plate. These two plates are what? Parallel, right? So we can say that this is a system of parallel plate. Suppose আমাৰ যেটো fixed plate আছে ওপৰটো এটা plate আছে তলতো এটা plate আছে, so ইয়াৰ area to suppose A আৰু তলৰ যেটো area হেটো suppose A. Okay, so we are assuming linear profile, linear velocity profile. আগৰ ক্লাছত আমি ডিসকাস কৰি আহিছো linear velocity profile হোৱা মানে কি যেটো আমাৰ shear stress হ'ব is in this part, in this part, in this part, in this part, that is every point the shear stress remain constant. Why this is occurs? So আপোনালোকে আগৰ ক্লাছত চাব পাৰে because tau is proportional to 1 by slope. আৰু যদি linear distribution হয়, linear distribution মানে কি? This is the linear distribution, so slope to everywhere কি same. যদি slope to same থাকে obviously tau same হ'ব because tau is equal to mu by slope আৰু mu to কি হৈছে constant parameter আৰু slope to কোনো ধৰণৰ variance নহয় in case of linear profile, right? So I can say that it is constant. Okay, so we have to find first shear stress. With the help of shear stress we can find the force also. Why? Because in normal cases what shear stress is nothing but applied force divided by area. So from here I can determine force is equal to nothing but tau into area. Area is what? This plate area, right? So force is nothing but tau into area. Very simple. আৰু আমাৰ যেটো from physics forceৰ লগত যদি আমি velocity multiplied কৰি দিও then আমি কি পাও power পাই যাও, right? So এইটো কেতিয়া valid হ'ব? এই দুটা expression valid হ'ব only for linear profile, right? Find the value of the force required and power required to maintain at the top plate. আমাক top plate সুধি দিলে যে কিমান আমাৰ power লাগিব কিমান আমাৰ force লাগিব। so top plate area টো যদি A হয় shear stress to constant থাকিব and it is tau, so force is equal to tau into area কৰি দিলে আমি কি পাম force পাম। from this expression we can say. Okay, আৰু forceৰ লগত যদি আকৌ আমি velocity multiply কৰি দিও, if we are multiplying velocity with force then we can get power. Okay, so এনেকুৱা questions আহে কিছুমান বিশেষকৈ কম্পিটিটিভ এক্সাম আপোনালোকে যদি দিব যায় any kind of central exam, so তেনেকুৱা ধৰণৰ questions আহি যায়। so আমি জানো as per Newton law of viscosity tau is proportional to velocity gradient. Okay, that means tau is equal to mu. Mu is nothing but dynamic coefficient du by dy, right? Or du by dy ki slope, right? So force is tau A. I know force is tau A, and if we substitute the value of mu du dy in this expression we will get mu du divided by dy. Here du মানে velocity আমাৰ ইয়াতে suppose দিয়া আছে u, v to আমাৰ velocity দিয়া আছে, right? so আমি ইয়াৰ জায়গাত আমি লিখিব পাৰো du ৰ জায়গাত আমি লিখিব পাৰো velocity for this case, and dy মানে আমাৰ depth to দিয়া আছে, depth to আমাৰ কিমান দিয়া আছে, this is h, top plate ৰ কাৰণে আমি উলিয়াই আছো, so h মানে y. okay, that means mu u by h into a. okay, but you can say mu u by y into a. okay, if the velocity profile is not given, যদি আমাৰ velocity profile টো দিয়া নাথাকে তেতিয়া আমি সদায় linear বুলি assume কৰি numerical বিলাক কৰো। okay, so হেতুৱে, so h টো গম পালো আমাৰ du মানে velocity difference, bottom plate of velocity is 0, upper plate of velocity is v minus 0 divided by h, that means we are getting v by h. okay, so if you substitute tau is equal to mu v by h then we will get power as power to আমি কি পাও, power is basically force into velocity, right? Correct up to this? So আমি জানো force মানে কি force মানে tau into area tau মানে কি tau মানে আমি এতিয়া derive কৰিলো mu v by h right mu v by h হৈছে basically tau into area is a then again we have velocity term because of power because power is a multiple of force into velocity so finally we'll get power is equal to mu v square by ah mu v square by ah বা আপুনি any depth যদি উলিয়াব যায় তেতিয়া we can say power is এই ফৰ্মুলাটো মনত ৰাখিব ট্ৰাই কৰিব power is basically mu যেটো আমাৰ dynamic coefficient of viscosity হয় into what we have velocity square into what we have area and divided by depth depth is y so mu v square area divided by y and যদি আমাক সুধে suppose top plate to move নকৰাকে আমি ৰখাব বিচাৰি আছো তাৰ কাৰণে second layer টোত বা দুটা layer আছে suppose first layer ত এটা force লাগি আছে second layer ত এটা force লাগি আছে so viscosity force টো যেতিয়া আমি overcome কৰিম কৰিবলৈ আমাক এটা force লাগিব that force is suppose force required and for movement or for critical movement f required should be equal to f viscosity যিমানটো আমাৰ force লাগিব এটো viscosity force opposite direction ত act কৰি আছে so force required equal to force viscosity right so these two are very very important formula যেটো আমি discuss কৰিলি so এতিয়া questions বিলাক কেনেকুৱা how much force is needed to hold the bottom face so bottom face ত কিমান force লাগিব suppose water to jate move nokore so obviously we will work against the gravity so amar jeto against the viscosity sorry against the viscosity so amar jeto viscosity hobo ter against it ami kaam koribo lagibo right so jehetu linear velocity profile ami assume korilom so tau is same for all layer upor layer to tau same hobo tar pisoto same hobo tar pisot same hobo because it is a linear profile slope is same right so that means stress amar topot jiman thakibo bottom to himan thakibo ami topot step uliasilo tau into a that is mu VAH and that is nothing but it is equal to force bottom এনেধৰণে power bottom is force into v bottom or লগত আমি যদি multiply কৰি দিও তেতিয়া হলে we can say that it is same so we can have for linear profile area to আমাৰ same থাকে then stress is also same force is also same but power is not same because আমাৰ যেটো velocity হয় this velocity may vary okay but power is not same for all layer because velocity is different so velocity profile to sauk eneke ahe so yat velocity belag thakibo yat belag thakibo yat belag thakibo so velocity difference hoy karone power change hobo but force to change no hoy force is basically tau into a force is basically different so there is no sense okay so now we're going to discuss some important numericals which are asked in any central government exams or sometimes in any competitive exam which is conducted by DTE tenka bilakot ahe numericals aru ajikali trend to change hoise APSC o kisuman numerical die so we have to know some numericals also okay so suppose amak eta questions di dile like this okay you can say that's like this consider the fluid flow between two infinite horizontal plates which are parallel okay the gap between them are 50 mm. The top plate is sliding parallel to the stationary bottom plane at a speed of 3 meters per second. The flow between the plates is solely due to the motion of the top plate. The force per unit area required to maintain the bottom plate stationary is bottom plate tot amar jeto force lagibo hetu uliabo koi ase right viscosity of the fluid or viscosity dia ase and density dia ase okay density is given as well as viscosity is given okay so I have to find the force per unit magnitude to maintain bottom plate stasis jodi if you draw the figure of this particular equation or this particular equation you see that the gap is 50 mm amar topot jeto plate hoy 3 meter per second ot goi ase and obviously since it is a linear profile at the bottom the fixed plate is there and here velocity is 0 right aru amar jeto mu value to dia ase 0.44 kg per centimeter square so if you try to determine du by dy du amar kiman hoise yat 0 ase upor 3 ase so velocity difference is 3 Then what is the height? Height is 50 mm. Jodi ami meter convert koro 0.05 meter. Okay. So I know as per Newton viscosity law, mu into du by dy. What is mu? Mu is given 0.44 kg per meter cube. That is dynamic viscosity. Du value to ami palo tini. That is difference between this velocity and above velocity, right? And dy is the distance of the gap. That is 0.05 meter. So from here I can get the tau. Okay. After getting tau, আমাক সুধিছে আমাক কি সুধিছে আমাক বেসিক্যালি টাওয়ার ভ্যালুটোৱে লাগে কাৰণ আমাক ফোর্স পার ইউনিট এরিয়া লাগে বটমত অবভিয়াসলি বটমত হুদক বা টপত হুদক সবতে সেমে হ'ব বিকজ this is the linear profile case, right? So our correct answer to is 26.4 Newton per meter square. I hope আপোনালোকৰ clear হৈছে. So we'll move to the next question. Question number 2. Okay. So question number 2 কি সুধিছে? Let me go to question number 2. An incompressible fluid that is kinematic viscosity দিয়া আছে but our formula কি লাগে dynamic viscosity লাগে. So we have to find first dynamic viscosity from kinematic viscosity. Okay. So kinematic viscosity to দিয়া আছে 7.4 into 10 to the power 7 meter square per second. Specific gravity দিয়া আছে 0.88. It is held between two plates, parallel plates. If the top plate is moved with the velocity of 0.5 meter per second, while the bottom one is held stationary, the fluid attains a linear velocity profile in a gap of 0.5 mm between these plates. The shear stress in pascals on the surface of the top plate. So top plate or shear stress to amak lage. So how to determine it? So let me draw the figure. What will happen? So you can say here. See, this is basically our question. The gap is 0.5 mm. Velocity is 0.5 meter per second. Okay. And amak yar shear stress to like a top plate, alright? So amak dia ase kinematic viscosity 7.4 into 10 to the power 7 meter square per second. Aru ami jano dynamic viscosity or kinematic viscosity relation to hoise kinematic viscosity is mu by rho. I know specific gravity. So from specific gravity we can determine 1000 into 0.88 we can determine as 8880. Okay, 880 raw value to pai galo 880. So I know mu, I know raw, so I can determine the I know v, I know raw, I can determine the velocity of mu. Okay, so as per formula, as per Newton law, I can know tau is equal to mu du by dy, or mu mane v h. Okay, v hoise amar 0.5, h hoise 0.5, right? So from here I know the value of mu as a raw into v. Raw to ami 880 ulialo, v value to ami pai galo, v value to ami kiman palo, v value pai galo raw value to 7.4 into 10 to the power 7 di ase, aru jitu amar mu value to ami basically pai galo from this 880 into 0.5 to amar asle velocity, right? So v value 7.4 into 10 to the power 7, raw value to 880, and mu value 0.5. Okay, so after that if you do the calculations, so eto ami 0.5 mm to meter le convert korilo, h or value to I'll get 0.6512 Newton per mm square is the correct answer, right? So question number 3 to jodi apnaloke sai, if you see the question number 3, what will happen? Question number 3, this one. Let me go to question number 3. Question number 3 to amar eta figure dia ase basically a solid block, amar solid block eta ase 2 kg mass slide steady at a velocity v along a vertical wall as shown in the figure. Figure eta amak dia ase, figure to apnaloke dekha pabo olop pisote. A thin oil film of thickness h 0.15 mm provides lubrication between the block and the wall. The surface area of the face of the block in contact with the oil film is 0.04 meters square. The velocity distribution within the oil film gap is linear. So velocity distribution to linear dia ase as shown in the figure. Take dynamic viscosity dia ase 7 into 10 to the power minus 3 pascal second dynamic viscosity dise, aru amak ki dise dynamic viscosity dile obviously density by specific gravity dibo lagibo, so that I can convert mu. So dia ase acceleration due to gravity dia ase 10 meter per second square. Okay, so আমি যদি oil to neglect karo terminal velocity v to uliabo koise, what is the terminal velocity, right? So this is the figure. This is impermeable wire আৰু ইহঁতৰ মাজৰ গেপটো হৈছে 0.15. This is 2 kg. This is V. V টো আমাৰ ডাউনৱাৰ্ড ডাইৰেকশ্যনত আহি আছে. So 2 kg এই ৱেটৰ আৰু এৰিয়াটো আমাৰ কণ্টেক্ট এৰিয়াটো 0.04 মিটাৰ স্কোৱাৰ দিয়া আছে. So let me solve how to solve it. Okay. So here see. This is a 2 kg weight আৰু ইয়াতে আমি প্ৰথমতে shear stress উলিয়াব লাগিব, right? So how to determine it? Contact area to আমাক দিয়া আছে. So shear stress যদি আপুনি ইকুৱেশ্যন বনাব যায়, what you can see, তলত আমাৰ weight এক কৰিব mg, mg তলত weight কৰিব আৰু ওপৰত কি হ'ব, ওপৰত shear stress আহিব opposite direction to that fluid, right? So এইফালে আমাৰ আহিব shear stress. So shear stress is how much, or shear force is how much? Tau into a. Area দিয়া আছে contact area we know. I know the value of tau. I know the value of mg. So from here, one unknown is only there, that is mu. So that is v. Okay. So tau মানে কি mu into v into a. I know value mu to আমাক দিয়া আছে. Mu value to আমাক দিয়া আছে 7 into 10 to the power minus 3. It is dynamic viscosity, right? Into v. V to আমাৰ unknown হয়. H or value to আমাৰ height to দিয়া আছে 0.15 into 10 inverse 3 meter, right? আৰু এৰিয়াটো আমাক দিয়া আছে 0.04 মিটাৰ স্কয়াৰ আৰু mg মানে কি 2 into 1020 কিলোমিটাৰ. So from there I can get the terminal velocity as a 10.714 meter per second. Okay. Next question number 4. আৰু এটা questions আহিছে, question number 4. Let me discuss the last question of this particular video. Okay. So এটোত কৈছে কি, the equation of a velocity distribution over a plate. So plate or velocity distribution equation to dia ase. Equation to say apnaloke gom paise 2y minus y square. That means it is a parabolic equation. Parabolic means it is a non-linear verification, non-linear variation. That's why ki hobo protecto point shear stress to amar beleg hobo, slope to karon beleg. But u is the velocity in meter per second at a point y meter from the plate measured perpendicular. So mu value to dia ase 8.60 points. Shear stress lage 15 centimeter from the boundary. So 15 centimeter shear stress to amak lage. So what I can do, this is the velocity profile. It is u is equal to tu minus y square. So find tau at 15 centimeter from boundary. So boundary pa 15 centimeter amak tau lage. Suppose it is 15 centimeter, I have to find the value of tau. Tau kiman hoy? So I know u is equal to 2y minus u square. Then amak mu value to poise dia ase. Poise to ami convert kori lobo per Pascal second divided by 10, because ki 1 poise is equal to 1 Pascal second is equal to 10 poise, right? So he karone ami ki kor poise or pa jeti ami divide Pascal second le nim dohere divide kori dim. So divide kori diar loge loge hoy gol 0.860 Pascal second. Okay. So tau y equal to 15 centimeter lage mu into du by dy. Du by dy kiman hobo? Amar velocity to kiman asile 2y minus y square. Jodi ami differentiate koru with respect to y, so 2y mane we can get 2, and y square means 2 minus 2y. So it is after differentiation. So I can get the velocity gradient, that is 2 minus 2y. I know the value of mu. Mu is 0.860. 2 minus 2 into 0.15, and tau is there. So I have to find the value of tau. I know mu value, I know y value. So I can find as 1.46 Newton per meter. So hekhini asile ajer video to. So basically আমি numerical চাৰিটাও discuss কৰিলো. যদি আপোনালোকে numerical কেটা বুজি পোৱা নাই, then comment section জনাব, I will help. Okay, চাৰিটা numerical discuss কৰিলো যিবিলাক previous year gate exam আহি গৈছে. So হেখিনিও আপোনালোকে জানি থোৱাটো ভাল হয়. So thank you for watching. In the next class we will move further some theorem regarding fluid mechanics. So thank you for watching. Have a nice day. Thank you.